All right, foundations, day one of online learning. It's going to be weird. We know that. But the goal of moving forward with this is step one, you're going to be watching videos first every morning for about 20 minutes. It's going to be a combination of myself going through things we need to know for the day. So think of this as like my model. Think of it as me going through the resource page. You will also be watching videos from other people teaching the same material, just in a different stance. So think of it as 3 different resources you have for the entire lesson, and you're going to utilize that throughout the entire rest of your 8 to 9 o'clock math block. So feel free to take notes during this time. Feel free to take screenshots. You'll be able to refer back to this throughout the entire hour of math. So sit back, relax, and we are going to start this week with just Q3 review. So we're going back to the very, very beginning, and our first unit was radicals. So we know whenever we do radicals, top of every page, we're writing perfect squares. 1 times 1 gives us 1, 2 times 2 is 4, and I'm going to go so on and so forth through the entire list till we get the top 10. 25, 36, 49, 64, 81, 100, and we'll even do 121 and 144. So we know we need to utilize these every single time we simplify anything. So in today's packet, we're just breaking it down simply between simplifying and then operations. So we're going to give some examples of both for you to refer back to, and we'll start with simplifying. So very basic one, let's think about here, radical 28. So we have a radical that's there. We know we need to find one of these top perfect squares that goes into 28 evenly. So when we break it down between 2, I know the first perfect square I can think of is radical 4. And 4 times 7 gives me that radical 28. Finally, the perfect square is going to come out. We keep the non-perfect square in, so my final answer becomes 2 radical 7. Easy, nothing crazy. The only other one I want to kind of take a look at is, what if we have a number that's on the outside already? Let's say we got 3 on the outside. And let's say, for example, we got a radical 72. Well, again, we got to think about perfect squares. Now remember, I want the biggest perfect square that can go in. So a lot of times we have people saying 9 and 8 for 72. That's not wrong. However, since it's smaller, we have to keep breaking down and breaking down. I want to do it in as few steps as possible. So the biggest number that goes into 72 would be, what do we think? Think about it. What do we think? 36. So again, if you're not sure what that number would be, calculator all day. Utilize the calculator to check each one of these perfect squares one by one as you go through every single one of them. I know Shinara does a great job of doing that. I've seen Amanda do a great job of doing that. So make sure that you're utilizing your tools just like we would in the classroom. So now, the only step that's different here is that we can't forget about this first guy here. 3 comes down for the ride. Radical 36 turns into 6 because that's a perfect square. And the non-perfect square 2 stays in. Finally, we multiply the coefficients on the outside. And 3 times 6 gives me 18, radical 2. So right there, that's your whole entire little index of just simplifying radicals that's there. So again, you have about 2 pages of it. This is going to be simplifying. Just so you have that going right down there. After we get there, then we have a little mix-up of operations. So we need to add or subtract, multiply, and divide. So I'm going to split this down the middle. One side we're just going to do adding. The other side we're just going to do multiplying. Again, it's the same exact steps for subtraction and dividing, so just apply the same rules as you get more questions in the packet. So continuing on, we'll start. We have adding and subtracting. Hopefully you remember the one rule that we need for this. And when we have adding and subtracting, it is super important to remember we need to do what first? Simplify first. Gotta simplify first here. We gotta make sure these numbers are broken down as much as they can because we can only combine like radicands. Hint, hint, that's a nice little fill in the blank you're gonna have on the resource page in the packet. So let's say, for example, we have radical 24 plus, let's see, radical 45. So we have two of these. We're going to break them down individually one by one. Again, we're looking for perfect squares that go into both. So 24, we know is going to be 4 and 6. So I got my rad 4. I got my rad 6. 45 is going to end up being rad 9. Actually, let's make this a 54 just to make it even. Rad 9 and rad 6. So we finish them up. Perfect square of 4 is 2. 2 comes out, the 6 stays in. Radical 9 is 3. 3 comes out, the 6 stays in. And finally, our last and final step, we treat these like variables. We only combine the outsides. 2 plus 3 is 5. We keep the insides alone. 5 radical 6 is our final answer. So remember, only combine like radicands. If you would end up, let's say, a 2 rad 6 and a 3 rad 8, can we combine those? Absolutely not. We're done right there and we let them sit. Easy enough. And then finally, our last objective, we have multiply and divide. So the big thing to remember here is it's the opposite of this. For multiply and divide, we must combine first. We don't want to break down first multiplying and dividing. We're just creating more work for ourselves as we go through it. The goal is we want to create 2 radicals into 1 and then break down at that point. So let's see a little example of radical 12 times radical 6. So normally we know we can break down 12 and break it down with 4 and 3, but then we're going to have to be multiplying outsides and insides and insides and outsides. So if we multiply them together first, 12 times 6 ends up being radical 72. Okay, now I have one radical. I go right back to my steps up top. I break that down, and all perfect square that goes in there is 36. Hopefully this looks familiar because we just did it right here. So when you have a familiar radical, you can kind of save some time and work right back from where we were. We know radical 36 gives us 6, and radical 2 gives us 2. The only thing that makes these tricky sometimes, remember, you're going to have some questions in the packet where you're distributing radicals and you're multiplying coefficients and everything like that. So remember the key thing that we talked about, outsides with outsides and insides with insides. You can only work with coefficients together and only work with radicands together. Again, this is review. It's been a while since we did it. So we're going to take each day, day by day, to just go back through each one. Everything you need is here. Remember, write out your perfect squares on each page of this packet if you need it. Because your objective now that this video is over, you have this as your guide. You can come back to this, rewind it, record it, and have everything there for your access. You have the 2 YouTube videos you're going to watch that breaks down exactly what we just did here. It's just someone else kind of running through the same exact way. And finally, then the packet for the last 40 minutes is going to be on your own. So remember, this packet needs to be completely finished. I need to see work on every single one of these. So I need to see this step of what perfect squares got broken down and the finalize that you have each time. If you just end up writing me rad 28 is 2 rad 7, you're looking at a 50 or less, no matter what. Show the work, refer back to the video, complete the packet. And that's our day one video. Good luck, foundations, and I'll be around for questions. Take care.